everyone, welcome back to the channel. Today we want to speak about the solution of one of the latest LeetCode contents question, fill a special grid. Today we are diving into the divide and conquer technique for matrix construction, a pattern you'll see in this problem, construct the matrix, gray code, and even Hadamard matrices. These problems appear often in contests and interviews, and we are going to break it down step by step. So hit like button and subscribe if you are into mastering algorithm thinking. Now we go through our question. First of all, what is our question? You have a non-negative integer n, and then by this integer n you have two squared n multiple squared n grid. Means that you have a matrix and you must fill this matrix with special integers from 0 to squared 2n minus 1 to make a special matrix with special rules. When you have a special matrix with a special that must become filled with special rules, this time you must thinking about the divide and conquer technique to make a special matrices by a recursive technique. What is the rule of this question? You can see that all numbers in the top right quadrant are smaller than those in the bottom right quadrant, and all numbers in the bottom right quadrant are smaller than those in bottom left quadrant, and all numbers in the bottom left quadrant are smaller than those in the top left quadrant. Each of its quadrant is also a special grid. So step by step we go to the details of using these techniques, and then we can see our code. First of all, as I've said, when you have such a question, you must use the divide and conquer for matrix construction, and I've said you have some examples like Hadamard matrix or recursive grid. All of this such a question use these techniques. So when you see something like this, like you have a grid, you have a matrix, and you want to fill it, and there is a special rule, then you must fast go to find how to use this technique to solve your question. Here, what is the general method? I want to mention what is the general method in general case, and then we go to our question. You must, first of all, you must find an original matrix. For example, here, let you have a first of all, when you want to use this method, you have a 2 multiple 2 matrix. You can find a small one, a 2 multiple 2 matrix, and then you use this 2 multiple 2 matrix to make a 4 multiple 4 matrix. Means that you just copy this matrix to one of this part, and then by adding and changing some numerically you make the new matrix based on the original one. So in general form, that is you can see here, first of all you have an original, a smaller one that that have all the rules that you find in your question, and then you can see just copy this original and add it some number that we call it offset 1. How we choose offset 1? You must a little innovation, and also you must obey the rules. And then you have a copy of original here with adding the offset 2, and also the original copying and added the offset 3. So it's the general method. In all of these cases, we use this general method. Now, how we solve our case? In our case, as you have seen before, it said that the top right quadrant are smaller than bottom right quadrant. Bottom right quadrant is smaller than bottom left quadrant. Bottom left quadrant is smaller than top left quadrant. If we want to visualize this rule to better understand, it's the smallest one. That when it becomes bigger, I change the minus to a plus to better visualize it. So it's the smallest. Then we have it that it's bigger than this one, the smallest one. It's the next step, and it's bigger. It's the third step, and it's the biggest one. So if we want to make our case, we make the original the smallest one, and then step by step, by adding some offset to each of them, we make all of them, and then we construct our new matrix. But how we do it? As I said, we put the original one here, and we call it the small because it's the smallest part of our new matrix. And then we put we copy it and put our offset as size multiple 1. The size is the size of original. So it will be like this, and you can see it's bigger. So we obey our rules. And then we put it to multiple size. Again, I can obey my rules, and it's bigger than this one. And at last, the last offset number is this, the triple of size. That will be our biggest. I choose this offset, and by choosing this offset, I can obey my rule and construct the new matrix by the original one. Now, after we explain our cases, we will go to our code, and you can see how we will write it in Python. Okay, now we want to see our Python coding. As you can see, I've sent it and it's accepted. Now we go to the question to see my Python code. Here are some examples that you can find it in the website to understand better how the rule works. And here is my solving code. You can see that first of all, I made a small matrix. It's the first matrix that have just 0, and then based on this small matrix, I construct my new matrix by the rule that I have explained it before. And And here by writing this, we can have the size of current grid, and then the size that we make our offset number comes from this m, you can see. And then I've defined my offset, and here you can see how I construct the top right matrix, bottom right, bottom left, and top left. When we make all of this matrix, that you can see it's the small plus the offset. The first offset is 0, the second offset is size, the third offset is the double of size, and the last matrix is the constructed by the small added to the triple size. So triple size TL is our third offset, and now we made all of these parts. Now we must attach all of them and make our new matrix. To doing this attaching and construct it, we use a special NumPy in our Python, and you can see first of all we use the special function hstack. The hstack use to attach two part of matrices horizontally, and you must first of all you must call the NumPy, and we call it, and then we named it as NP in our code to make it easier, to write it easier. And then here you must first of all call it and then use the hstack. And at last we we use the vstack that attach two matrix vertically, and the small will be our new grid. The small first of all, the small here was the first grid, was the first matrix that was only 0, and after all of this construction, the small becomes the new full grid, the new matrix, and we return it to by a toolist to make it a better readable format for our Python code and for our contest. Now, if you enjoyed this breakdown and want to see more contest level pattern explained simply, give this video a thumbs up and subscribe for weekly uploads. And if you ever struggle with a recursive matrix problem, let me know in the comments. I'll help if I can. Thank you and have a nice day.